All right, but then of course there's the rest of the focus lesson. When do I multiply fractions? So we're just reiterating that for them. When you have to find a fraction of a fraction, part of a part. You see how I did that? Both that are in there. How can I multiply fractions? You can use a procedure, algorithm, area model, or bar model. This is another chart that you guys are going to work on. All of your students will work on. Okay, so you can see them all in the same space. Algorithm, so 3/4 times 5/6. And in this case, you know the algorithm where you just find the GCF of any numerator and denominator. So here we have the 3 and the 6 with a common factor. The GCF of 3 and 6 is 3. So divide these numbers by 3. There, I did it. 3 divided by 3 is 1. 6 divided by 3 is 2. No common factors here. So becomes 1 times 5, 4 times 2, just straight across 5/8. I know you guys have taught this before, so you can show them that, okay? And usually it's the high kids that are like, I like that. I'm going to learn that. I'm going to apply that. I'm going to use that. To help with the discussion of what it means, the conceptual ideas behind this expression, you can use the area model. Is this how you guys did it?
Yes. Well, not with dots.
Yeah, so.
Oh, you dotted.
Well, the double cross hatching is the dots, just to reinforce that. No, I did that after I looked at that.
I just put a dot wherever there's double cross hatching. Okay, so the whole from here to here is 1. We'll break up that quantity into sixths. Okay, and then define 5/6. Okay, so I defined it with the brackets. So everything here represents the 5/6. Right this way, it's an intersection of quantities. 3/4. So from here to here would be 1, but we break that into fourths and define 3 of the 4 parts, 3/4. So that's this. It's I know that kids can do this because I taught 5th grade and they learn it.
The challenge
they don't get it right away.
Organizing it and making it really nice and neat.
Yeah, so and isn't that what we want from the kids anyways? We have to give them the kinds of tasks that are asking them to be neat and organized in their work. You know, you don't have to use a ruler for everything, but you can get better and better at doing the work correctly. You know, writing it neatly, using lines on the page that are there on your page. So then we just do the shading this way for the 3/4, and that's an orange, and then the 5/6 is here, and then the intersection. So you yield 15. It yields 15 partitions that are double shaded. Using the different colors helps. Okay. So you end up with, and out of the total number of partitions is 24. So you end up with 15/24, which is already correct. But then you can simplify, which the kids are doing already. 5/8. All right, the bar model. So here, the bar model, we are just linearly representing 3/4. Again with the bracket, showing 3 out of the 4 parts. But how do we negotiate the other fraction, the 5/6, right? Well, we look at the denominator, the 6. So then inside each fourth, because here's 1/4, here's another fourth, here's another fourth, here's another fourth. But inside each fourth, we can create sixths, right? So we create sixths inside each fourth, and we can shade in. I think you guys already all did this. Yeah, so you're good with it. You're just repeating myself from what you guys have learned in the past. So 5/6 here, 5/6 here, 5/6 here. And this is also 5/6 shaded in. But I didn't put the dots in there. Why did I not put the dots in there?
Because that was not used in the original amount.
Yeah, it's not part of the 3/4, right? So we're looking at all the 5/6 that are in the 3/4 region, because we're looking for an intersection of the 3/4 and the 5/6. So, well, the ones that are counted then are these 5/6, these 5/6, and these 5/6. 5 plus 5 plus 5 is 15. All of the partitions that we've created, though, number 24. 6, 6, 6, and 6. 4 times 6, 24. So, again, I've been very explicit in how I made my chart. So it's 15 shaded partitions inside the 3/4 region and 24 partitions in all. Right?
Wait.
So, can we teach them either area model or bar model, or do they need to understand both?
Well, you can show them both. The thing here, yeah, the thing here is not necessarily like what I've said in the past, that because you could turn the proficiency of making an area model for any multiplication expression, or the proficiency of making a bar model for any multiplication expression. You can add that to your curriculum, but when you add things to your curriculum, it takes time.
Right. That's what
Right?
I'm asking.
And then not every kid is going to get proficient in a short amount of time on doing this, creating this. But this does help some kids, and they have the opportunity to go, like imagine that this is all we show them, right? Then math stays in the realm of, oh, okay, it's weird. It's weird that there's a procedure. I don't understand why I'm doing that. You know, can you make a picture for that to explain what this means? No. You know, and then math just stays the way it always has stayed, which is like this weird series of steps, right? But the picture, the use of the picture for the teacher is in, you know, if you become proficient at it, then you can, for any problem, make a picture for it and then facilitate a discussion about the meaning, you know.